Assalamualaikum. I'm the second year student of Marine Science. My name is NORHASLINA BINTI ROSNI, and today I'm going to talk about the diversity of marine phototroph. So let's go. Here we're going to talk about the phototroph. Phototroph is an organism that uses visible light as their primary source for metabolism, and phototroph will also transform the energy of solar radiation into the chemical energy in organic substance, and we will use their energy as the starting point of the energy flow in the marine ecosystem. And the energy flow is important not only for the marine environment but also for the development of new marine biotechnology. And as we can see about phototroph is serving as a primary producer and contributing to the transformation of light energy into the chemical energy. And not only for that, phototroph is also the organisms that can synthesize ATP, and they will synthesize the ATP using the transmembrane electrochemical potential of protons with CHP by pumping up protons from the membrane one side to another side based on the lab energy. So, photosynthesis organisms are the only part of the phototroph, as we know. So the primary, as we can know, phototroph is the primary process, but the primary processes are not the only organisms that can produce organic compounds from organic carbon, but also the organisms that can produce ATP using the sunlight energy. As we can see, the phototroph is almost equal to the primary processes in this chapter. So another slide, we will talk about the flow in the marine of phototroph. So next we go. Hi, in this slide I will talk about the flow of diversity marine phototroph. Actually, there are 7 series that participate in this flow, which is 1970, 1980, 1996, 2000, 2007, 2010, and 2011. So in this first year, which is 1970, in this year the primary producer mainly performed in the atom and the fragates. And the list of 1970, the cyanobacteria cyanococcosis were found dominantly in the area of tropical and subtropicals. So in the next year, which is 1980, the vinyl chlorophyll A has found using the technique from the high plasma liquid chromatography, which is HPLC, and a cell detection technique using the flow cytometry. And this one, we found the cyanobacteria. New cyanobacteria, which is fluorococcus, and this fluorococcus will undergo the oxygenic photosynthesis. So, in the other years, which is 1996, in this year we will talk about the oxygenic photosynthesis using the far red light, because the cyanobacterium, we found the cyanobacterium azarochloris, because in this cyanobacteria they have chlorophyll D, and chlorophyll D can absorb the far red light. Aenosygenic photosynthesis bacteria, which is AAPB, consists of BCLA. And then the chlorophyta and the heterochromita, is also known as the eukaryotic phytoplanktons. The next one is the 2007, and the 2007 is the phylum of Algae, which is Physobilophytes, and we found this, but this one is not belong to the any phyla of Algae. So in the 2010s, we found another red shift. Before this, we found the chlorophyll D in the 1996, and the 2010 we found another, which is chlorophyll F. Even the chlorophyll F is same as we will not use this again. And this one is widely distributed in this year also we were widely distributed of physophile types and many undescribed species. So in the last years, which is 2011, red permanence, which is the new phylum who detects by the metagenic metagenomic analysis and targeting plastic DNA close to the hepatocytes. And this one also widely distributed in coastal area of Europe and the Atlantic and the Pacific Ocean. So I will describe more details about one by one in the next slides. The second is the recognition of Phytocean bacteria dominant. So in the late of 1970, there is the development of the fluorescent microscopy and the accumulation of knowledge from electron microscope observation. So this found the cyanobacterium Cyanococcus spp, and they are predominantly distributed in the marine environment, especially in the tropical and subtropical regions. So this is a very tedious cell called mycocyanobacteria, which is the act as a primary producer in tissue, and they play a significant role as the primacy producers in this environment. So, in the late of the 1980, they have a new primary producer, which is called as the genus Prochlorococcus. Okay, Chlorococcus was found using the new development of the technique, which is high performance liquid chromatography, which is HPLC, and the cell detection technique using the cytometry. Okay, so these cyanobacterium contain the divinyl chlorophyll A, and they can perform oxygenic photosynthesis using the pigment, which is DVCSLA, which can efficiently absorb the blue light dominant in the oceans. So as you can see, this one is the next one is the third, which is the discovery of the Phototroph. So in the early 2000, there are two significant found, which is first the wide distribution of big anogenic photosynthetic bacteria, which is ADPB. They contain the bacteriochlorophyll, which is BCHLA. And the second one is the wide distribution of proteorhodopsin, which is the containing the bacteria. So in the 1973, the phylogenetically, which is ADPB, was derived from the non-sulfopocobacteria, which is anaerobic anosogenic photosynthetic bacteria in the alpha-proteobacteria. So the AAPB are the same with the anosogenic photosynthetic on the point that they can contain the bacteriochlorophyll, which is CHLA. So the details physiological role and activity of photosystem in all AAPB have not clarified the energy in the environment and act as the primary producers. So from the 1990 until the 2011s, they have three stages, which is first, oxygenic, second, the discovery of physokaryotic phytoplanktons, and the third one is the strange phototrophic microorganism, which is the hana.j microorganism. So for the first, oxygenic photosynthesis using the far light, which is in this one, which is the chlorophyll A is the indispensable for oxygenic photosynthesis, because chlorophyll A plays an essential role in light harvesting, energy transfers, and charge suppression in the primary reaction in photosynthesis. And they have PAR, which is photosynthetically active radiation PAR, which is this one is for the evolution light exchange for activity oxygenous photosynthesis. And in this article, in 1996, the chlorophyll D, which is redshift chlorophyll, which can absorb far red light for an almost 30 millimeter longer wavelength than chlorophyll A was found. And this chlorophyll can perform oxygenate photosynthesis. And for in this topic too, in 2010s, another red shape chlorophyll was found, which is chlorophyll F, as stated earlier this one. But chlorophyll S is from a cyanobacterium that isolated from the microbial mass on stromatolite at the coast of the Australia. So, this chlorophyll was not taken into account in the estimation of primary production in marine environment because we still wait for the further research to know the contribution of chlorophyll F to oxygenous photosynthesis in the marine environment. So in 2011, they found a new phylum which is Rapimonens. Okay. By using the same techniques, which is the metagenic analysis targeting plastic DNA. So this phylum is super close to the haploids, but they do not belong to any known phylogenetically. And this one is also widely distributed in coastal area of Europe and the Atlantic and Pacific Oceans. And same as the in 1996, this phyla is the phyla and the algae, which is the both candidates which have not been isolated and cultivated. So the characteristic in their morphology, physiology, life cycle, photosynthesis, and the productivity are not yet known. It might be possible for a further new phylum of phytoplankton, which has not been yet will be discovered. Okay, so the last one, which is in the 19, is the strange Phototroph, which is the unknown microorganism. Okay, the unknown microorganism, which is UCYNA, which is the cyanobacteriums like particle UCYNA, was detected by the same technique, which is metagenic analysis of nitrogen fixing, but in marine waters. So, this one is the first detected as a cyanobacterium, which has a nitrogenous chain for nitrogen fixation in pelagic water. Why they say like that? Because usually they found the cyanobacteria that grow by an oxygenate photosynthesis process, photosystem, a respiration system, and adjust for a carbon fixation system. So, this states that UCNA is a lack of photosystem too. So there's also the lack of this essential gene for free living suggests that UCNA might be a symbol in some organism, and they also maybe possess a complete gene for the photosystem one and contain chlorophyll too. So this one maybe they used to light energy for some activity, and this also says that it's unclear how the light energy absorbed by the photosystem one is in the photosystem one is in the particle. So it must be contribute to the transformation of light energy into the chemical energy. So actually it is all about the flow in 1990 into 2011. I will end my slide reference that I use as to explain about the marine diversity photograph, and this is the list of the reference. So if this one is the reference. So hope you guys enjoy my video, and see you again. Bye bye. Goodbye.